So what do you do if the du that you need is not exactly there? All right, every problem that we've done so far, whatever we picked for u, we then found du by taking the derivative, and lo and behold, that du just happened to be exactly there in the integrand. We were good to go. We didn't have to worry about any issues, okay? Obviously, that's not always going to be the case. How do we handle it? Well, these examples at the bottom of the page are designed to give you more insight in that regard, all right? With example 16, we have x times the quantity x squared plus 8 to the fourth power dx, right? Now, at this point, you start to get used to these types of problems. What should u be equal to? Yeah, it should be x squared plus 8. So we're going to make u equal to x squared plus 8. And when we find the derivative of that, we get 2x dx, okay? Well, we've got the dx, and we've got the x, but we don't have the 2, right? So how do we deal with that? Well, we want to put a 2 in there, but we can't just multiply something by 2 because it changes the value of the whole expression. Right? We know from elementary school, the only number that we're allowed to multiply by where it doesn't change the value of the item is 1. All right? You learned the multiplicative identity a long, long time ago. A times 1 is equal to A. It seemed kind of stupid at the time, but now is when we're really using it. We have to multiply this by 1. But putting a 1 here doesn't help us because we need a 2 there. So what do? Well, we multiply by a version of 1 that helps us out. Yes, we need the 2 there, but we're going to multiply that 2, and we're also going to multiply by a half. Now we've multiplied by 1. We just multiplied by 2 and then divided by 2, but we multiplied by 1. We haven't upset the balance of our expression. Okay, but we don't want 2x and a half and dx. We only want the 2x and the dx. So what do? We're going to move the 1/2 out front, which we're allowed to do because we know from our definite integral properties that the coefficients can go back and forth between the inside and the outside, and it doesn't affect the expression at all. So we're going to multiply by the 2 and the 1/2, but the 1/2 is going to go on the outside. The 2 is going to stay on the inside so that it can be subbed out and du can be subbed in. So what does everything look like when all is said and done? Well, again, we have the 1/2. That's been moved out front. And we have our antiderivative symbol. This 1/2 is no longer here because it's out front. We have x squared plus 8 to the fourth power, but we know that u is x squared plus 8. So we have u to the fourth power. Right? And then the 2x, which used to be x, but is now 2x, and the dx, the same thing as du, so they make the substitution as well. So basically, we're doing the exact same thing as before, except we just have this coefficient out front. No big deal. Just going to move it right down along with everything else, and at the end, we'll just merge it into the solution. Right, so what happens with u to the fourth when we antiderive it? Yeah, it's going to become u to the fifth over 5 plus c. Okay, but keep in mind that we still have the 1/2 out front. Okay, now we're going to, in essence, distribute that 1/2, but 1/2 of something that we don't know is still something that we don't know. So we don't have to worry about doing like 1/2 c or anything like that. It's still plus c, because c can be whatever number we need it to be. Okay, but the 1/2 times the over 5 means that we actually are going to be over 10. So we got u to the fifth over 10 now, and we're going to have our plus c. But let's kind of combine our steps right here. We know that ultimately we want to sub x back in. So x squared plus 8 is the same thing as u. So we're going to have x squared plus 8 to the fifth power. And this expression right here, that's our antiderivative. Not sure? Derive it. You're going to end up with the original green problem, x times the quantity x squared plus 8 to the fourth power. It'll work out. Let's take a look at 17 as well. Because 17, we have a number in there, but I'm not sure if it's going to be the right number that we were looking for. All right? 17, I've rewritten it ever so slightly because we're taking the square root, but I've written it as the quantity to the 1/2 power. That makes it easier to antiderive. It kind of saves me some space because I don't have a lot of space down here to work with. All right, what's our inner function? It's x cubed minus 1. So we'll make u equal to that x cubed minus 1. And du is equal to 3x squared dx, because that's our derivative of x cubed minus 1. Okay. Well, we need a 3x squared. Well, we've got a 2x squared, but we need a 3x squared. So we need to convert that 2 into a 3. 2 times what number gives us 3? Yeah, 3/2. All right, so we need a 3/2 there, because that'll allow us to cross out the 2's and give us the 3x squared. But again, we can't just multiply by 1.5, right? We can't just have that 3/2 there. We need the reciprocal on the outside. in order to counterbalance. Okay, now we've multiplied by 1. Now we can proceed. So we have the 3 halves on the inside to turn the 2 into the 3. So we have 3x squared, which is what du needs. And then we have the reciprocal on the outside. So what's happening? We've got 2/3 antiderivative, and then the 3x squared and the dx, that's our du. And then our x cubed minus 1, that's our u, so we're going to have u to the 1/2. Okay, so basically we're doing the same thing as before. We just have this extra 2/3 on the outside. All right, so continuing onward, we've got 2/3, and then we've got u to the 1/2, which is going to become u to the 3/2 over 3/2, right, plus c. So there's our antiderivative. It's pretty messy, but it's correct. Okay, we can modify this slightly. All right, we're dividing by 3/2. It means we're multiplying by 2/3, but we're already multiplying by 2/3. So 2/3 times 2/3 is actually 4/9. So what we can have here is we can have a 4, and let's get rid of our u. Let's put x cubed minus 1 back in. All right, that's to the 3/2 power over the 9, just as promised, plus c. And again, you don't have to have the 4 and the 9. You can have 2/3, then 2/3 again, and you'll be fine. Or that right there is our antiderivative. Okay, this one's a little more complicated than previous ones. Usually you're just putting a number in, like so, and it's reciprocal 1 over that number on the outside. But it doesn't always have to be 1 over. It can be something else. It can be 2/3, something like that. The one thing that we cannot do is we cannot put x's on the outside. If we're missing a 2x, well, it's okay if we're missing the 2. We can put the 2 in. But we can't just put an x on the inside and a 1 over x on the outside. That's bringing in an additional solution to our spot where our function would not exist. So only do this with numbers, no variables, as far as placing products on the inside and the outside. It can only be done with numbers.